Hi everyone, welcome to Adarsh Model Train. So today we will see how we can configure servo-based turnout using Node MCU ESP8266. So for that, first we will go to our GitHub page, which will be github.com/adarsh-model-trains. Once we go into this, we'll go into repositories and we will see Jmri Mqtt Spring Transformer wireless ecosystem. So here, as in the earlier tutorial, we have covered all the configuration, almost all the configuration for ESP and Arduino solutions. Here only two things are pending, which is MQTT CT sensor and IR sensor, and REST CT sensor and REST IR sensor. So I'll cover it going forward. So we'll be starting ESP solutions today, which will be, if you have following this tutorial from the start, I have already explained that there are two type of configuration. One is with Arduino and Node MCU, and another one is with directly with the Node MCU. So we are following the Node MCU configurations now. So it will be this part now with MQTT and REST API. So first we'll go to ESP solutions here, and today we'll pick up servo-based MQTT servo-based turnouts and signals. So we'll go into the home page. Here you can see everything is same, only we are not connecting the Uno or Mega to Node MCU. It will be direct connection to Pca9685 board, and we will configure the servo-based turnout based on that. So once we get into this, we can just download the source code. Let's download the source code here. Once source code is downloaded, I'll just extract the source code. Let's open the source code here. So in the source code you can see there are two there is a config.h. We'll just go into config.h. We'll just check the MQTT server username, password, topic where we're gonna listen. This is a ID, client ID, and today we are just we are testing only one server based turnout, so we need only one turnout board, light board 0, total number of board is 1, and we can just give here the open and close range. So open and close range, for that you can see here, if you can see here in the solutions here you can see servo calibration servo turnout calibration sketch is there. You can just use this, download this calibration sketch, and you can get the calibration number for the open and close position for the servo based turnout. And what you can do, you can just copy paste here for first position for servo motor 1, 2, 0, 1, 2, 3 up to 15. You can configure, total 16 you can configure here. So today we are just using only one board, so we don't need this. And just assumption, I have kept it here 1350 and 1650 are the number which we have derived earlier long back for calibration sketch. So if you are following this tutorial from the start, you must be knowing where these numbers are generated. So in this, everything is done, nothing has to be changed. Let's go and connect the, so I have this node MCU here. I'll just connect this node MCU. And let's change the port number here, port number 1430, and change the board type to node MCU 1.0. So board is correct. Let's compile this code. It will take time usually. So code has been compiled. So we can just upload this code now. So after uploading the code, it should be able to connect to the Wi-Fi, but not it should not be able to connect to the MQTT because we have not started the MQTT yet. So we will see how we can start the MQTT as well as Spring Transformer application and the Jmri for the testing purpose. So code has been uploaded. Let's see the CL monitor. So here you can see connected to Wi-Fi, but it should not be able to connect to the MQTT. So error in connecting MQTT, that's fine. Total number of configurations what we have configured. Turnout board we have configured 1. Only board number 40 with the index 0 has been configured here for the servo turnouts. So we are good with our configuration. Let's start the Jmri. Let's start the MQTT and Spring Transformer and do the other configurations. So now what we'll do, we'll start the MQTT. So for that we'll go to our desktop, MQTT configuration, Python start. So our MQTT has been started. We'll just open one more tab here, cd So before starting the Spring Transformer application, I just want to make sure we have the right configuration here. So we'll get into that. So we went into here. So these things are not required. We'll open the application.yaml file, which is our configuration file. If you are following this video tutorial from the start, you must be knowing all how to configure and everything. So node 1 is enabled, publishing to MQTT is enabled, REST API is also enabled, and light count 0, 2 LED signal count 0, 3 LED signal count 0, servo turnout count is 1 because we want to test that, turnout board is 1, and light board should be 0. So, and this is a topic where it will publish the data after transformation. So let's save it, and what we can do, we can just make it duplicate here. We'll go to the main page and we will go to Spring Jmri Mqtt transformer application here, and you can just download the jar file as well as the configuration file from here, and you can do the changes, everything. If you are following this from the start, you will be aware of that, how you can do the configurations and how you can execute that. So now if you see here, we have the jar file here, and we have configuration file and other property file which is required. So let's copy paste this. So our application has been started on port number 8090, and let's validate our configuration. So here in the same page in the Spring Transformer, you can see there are URLs. This will give you the all nodes whatever configured, and this is for the specific node. So here I'm just interested in node 1 today. So here you can see node ID 1 enable, publishing is enabled, REST API is enabled, light count 0, signal count 0, 3 LED signal count 0, server turnout 1, total number of turnout board is 1, light board count 0, node subscription topic where it will publish the data, and all other information. It will tell you that total number of light pin is required 0, 2 LED signal pins required is 0, 3 LED signal pin required is 0. For servo turnout, we need only 1 pin required on the board, and it will tell you total number of servo turnout board required is 1, total number of snap turnout required board is 0, and total number of light and signal board required is 0. And it will tell you how you can configure the servo turnout on the Pca9685 board as well as in the Jmri with what address. So if you see, Jmri address should be 40001, board number, pin number. So board number 0, pin number 0, it will send a throw signal. Board number 0, pin number 0, it will send a close signal. So only one pin is required for us. So here if you see, here, once we'll configure the PC9685 board, we can just do a, I'll explain about that part also. So now we'll go through the configuration, how we can configure the PC9685 board. So for that we'll go to the page from where we have downloaded the source code here. So here you can see from the node MCU, D1 will go to SCL pin of the PC9685 board, and D2 will go to SDA pin and SDA pin of that, and sorry, I was just pointing wrong. This side if you see, D1 will go to SCL and D2 will go to SDA line. Here you can clearly have written there. And if you are configuring multiple board, you can just chain it, and there is an external 5-volt power supply which you have to pass it to every board, and you can set up the common GND between these two. This red is optional, and you can power up from this port directly, and these two pins you can just take it from this connection only. So I'll show you what does it mean here. If you see, I have done all the configuration here. So if you see here, this is an external 5-volt power supply which is coming to this breadboard here, and from this breadboard, this black one is a common which we are setting up from here to this board, so that it will be line will be common across this. And if you see from node MCU here, this is from D1 and D2 we are taking it to ST and SCL line, and here red and brown which carries 5-volt we are taking from this breadboard. That's the reason we are taking this 5-volt power supply from here and passing it to node MCU, because we are not taking power from this board. And then here you can see, here this blue one is a GND and this white one is a 5-volt which we are passing it to PC96 board 85 board here. And this on the pin number 0 we have configured the servo turnout. So this is very simple configuration if you see. So what we will do is, we have started the applications and all. We have already tested from the endpoint. Now, so what we will do, we'll just start the panel pro first. So we'll go open the tool table turnouts here. We have to look for 40,001. So here is the 40,001, and what we will do, we'll just open the serial monitor also here, and we'll make sure that we are on the right network. We are on the right network now, and we will just refresh this so that we can ensure that it's connected to MQTT, because when earlier we have downloaded the source code, that time we have not connected to MQTT. Now everything looks okay. Let's fire up. So here you can see servo is moving, and I'll say close. I'll just show you more closely here. You can see here. So what I did, I have not stick all this turnout here on this board as well, as because just for demo purpose I want to show you. You can just get the proper calibration number. You can stick it into your layout, and you can stick it next to that or under the table, or whatever way you feel convenient, and you can test it like that. So if you see, it's based on the calibration number. And here you can see, based on whatever commands we are giving, it's taking up here. and here whatever data is published from Jmri to our transformer application, our application is handling everything and sending it back. Here also it will print the same information, and I already shown you how we can use the MQTT app, but I don't want to go into that because it's not required every time, because I already covered that part. So this is how we can do the testing, and in the next section we will see how we can do the how we can take the same exercise with REST endpoints. So stay tuned with us, and please subscribe to my channel. Till then, take care. Bye.